Now we're going to talk about constants rather than variables, which we've been discussing so far. Constants are just that, constant. It's an unchanging value. The compiler can do special things with constants and use them throughout the compile process without consuming the storage areas that the compiler would use for variables, because the compiler would need to keep those in special places in memory so that true values can be put into the variables and recovered, manipulated, so on, changing strings or adding values to numbers, that sort of thing. But a constant, we don't expect it to change, so the compiler doesn't have to take up space for it. Constants can be specified when you create them in decimal. There you see the decimal 123 that we know at 123. It's inside single quotes. That shows that that's a decimal value which will be defined into a constant. Octal simply has a leading zero, like 0173 is also 123 decimal. And hexadecimal, 0x7 Baker, or 7b, is again 123 in decimal, the value that we know. So that's some ways that you can specify constants and use different notations. Maybe those notations would make more sense to you in your application. Constants are created with pound define. There you can see 4 lines of code. Notice the pound define for PI, 3.14159, and an F for floating point right there. That will cause pi to be created as a floating point value and not just an integer. This one down here, max records, we've pound defined max records as 10,000. That will be an int. It's up to your compiler whether it makes it an unsigned int or not, but this will be an int. Max days of the month, 31, that is also an int. And then we defined at the bottom U.S. Census as 300 million. Now there we have to put an L on the end of that, and that will specify that as a long. So U.S. Census as a constant will be a long and will be used in mathematical functions as a long. So there, when we see casting later on, how values are cast to one type or another, depending on the math functions being performed on them, U.S. Census will already be defined as a long and make the math function that much simpler and the code that much faster. Here's a bunch of escape sequences that are generally used in constants or sometimes in string constants. You've already used one of them. Notice the backslash A, that's for alert, and there's backspace and form feed and all sorts of other things. You've already used the backslash N for new line. An R is a carriage return, there's a tab, and then you can use some special things like the backslash and 3 digits of an octal number or backslash X and a hexadecimal number to create sequences of special codes in your constants that you create. If you want to actually show a backslant or a single or a double quote inside a string constant, you have to escape it out like this with a backslash in front of it so that it doesn't get picked up as another backslash or as the ending double quote of a string. Remember, hello world started with double quotes and ended with double quotes? Well, if we wanted to put a single quote or a double quote inside the string itself, we would have to escape it with a backslash in front of it. There is a special constant, backslash 0, which is null, all zeros. So it also can be used mathematically, but we mostly use it at the end of strings and to show that the string is over. We don't use a length byte in front of the string like some languages or some implementations do. C programming relies on that null, and you can check for things to be null by comparing them to that quote backslash 0 quote that you see, which is null. String constants we've already seen, for example, hello world that we used in our first program. So hello world backslash n is a string constant. And when it's stored in memory, it's really an array of characters. We have HELLO space and world and the new line character, and then we have the double quotes to end the string. But in memory, we have hello world and a new line byte. And then there's really a null out here on the end. There's one of these backslant zeros or an end of string character, so that when C runs through memory and looks at this sequence of characters, there will be hello world, the new line, and then the null, so it knows where the string stops. So when you're defining constants, single quote A single quote is a integer value for the letter A, and that will be coded as the value of a constant. But that's very different from double quotes, A double quotes. That's the letter A, or the numerical value for it, and then there's a null next to it. So there's really two characters taken up there, because this is a string constant as opposed to this being a character constant. There's one more kind of constant, and that's the enumeration constant. And it's a little bit special. It's called enum. And there we have enum, short for enumeration. Boolean is the name of the constant. And we have an opening brace and a closing brace. So we have no is 0, because the first value inside the braces will be given the value 0, comma, and then the next value will be given 1, and so on out the list. Then we have a closed brace and semicolon to end the statement, the enum Boolean statement. Down here, we're going to make up an enumeration constant called months. And months can contain the value 1, 2, 3, 4, 5. As you see, we run down the line here. Notice we said Jan equals 1, January equals 1, because we, of course, didn't want it to start out by default and set January equal to 0. We need it equal to 1. So we can force that on the enumeration anywhere in the list, and the enumeration will just increment the number and run us all the way out to 12 out here. And we'll see later in some of our programs how you actually use something like this. But it's a good way of getting values into your code that are easily set up, and you don't have a bunch of pound defines and things like that kind of cluttering up your code. So enum is a nice thing to be able to use. And we're going to move onward to other types, operators, and expressions.